computer if necessary. All right, anyway, so here we have an absolute value inequality to solve. You know, the absolute value of something less than or equal to this. Okay? All right. So now what we're going to do is solve this. Okay? So how do we do that? Well, again, if you have the absolute value less than or equal to a positive number, right? You do negative that positive number less than or equal to whatever's in the absolute value, less than or equal to this number, to the positive number. You know, we have seen this before, but this is what you have to solve two inequalities here. Okay, and here it's really not that bad. You just have to remember x is going to be all alone in the middle. That's what you want. Okay, so what can we do? We have minus 12 here. Well, let's add 12 to everything. You know, you want to keep everything in balance, right? What you do to one side, you do to the other. So we add 12 to each side. We get minus 5x in the middle, less than or equal to 14. Greater than or equal to 10. Next, what do? Well, we divide everything now by negative 5, right? Again, we want x, not negative 5x, right? Okay, but here we're dividing by a negative. If you multiply or divide, there we go, fix my chair. If you multiply or divide by a negative number, you flip the inequality. Let me say it again. If you divide or multiply by something negative, you turn the inequality symbols around. Right? Here we're dividing by negative 5, so that's what we do to everything, but the inequalities get flipped. So we get negative 2 greater than or equal to x greater than or equal to negative 14 over 5. That's what we do. So altogether then our solution set looks like this. Notice what I did. I rewrote it slightly, not much different really, but it's the same thing. Negative 14 over 5 less than or, well, yeah. Negative 2 is greater than or equal to x, right? Greater than or equal to negative 14 over 5, which is really the same as this. And as an interval, this is what we get. Good. Okay, so that's what we get here. I didn't graph it. You're not gonna have to graph on the. You're not gonna have to graph the solution set on the exam. Okay. So, are there any questions on this one? All right. So here's another one then. So it's the same idea, right? We have something in absolute value less than or equal to 3. How do we solve this? Negative 3 less than or equal to that something less than or equal to 3. Right? We get two inequalities, 2 for 1, so to say. Okay, so what do we do here? Well, again, we want to get x all alone in the middle. That's what we want to do. Get x all alone in the middle. All right, so how do we do that? Well, so again, let's subtract 9 from each side first. You know, that's something we can do. Doing so, we get 4 times x less than or equal to negative 6, greater than or equal to negative 12. But we want x all alone, not 4 times x. So how do we get 4 out of there? We can divide. And that's what we do here. Divide every side by 4, right? So we divide both sides by 4. So we get x, as you can see. Okay. And again, what you do to one side, you do to everything else. Keep it all in bounds. So we get -3 less than or equal to x, and x less than or equal to -6/4, right? -12 over 4 is -3. -6/4 we get over here, which is the same as -3/2. But if you left it as -6/4, that's fine. So our solution set here is this. Okay, which as an interval turns out to be this. Okay, that was good. Are there any questions on this? Okay. Now, I know I'm going to go back to trig. I hope no one has any, how do I say this? Hope no one has an issue with that. I mean, my understanding is this trig is really complicated for students, so I figured it wouldn't hurt to review it some more. I mean, I hope no one has an issue with that. But let's suppose now cosecant of theta is 9/8. We're going to find all the other trig functions without trying to find theta. But we are assuming that theta is acute, meaning it's between 0 and 90 degrees. Well, again, we want to make a right triangle, okay, so that this is true. That's what we want. We want a right triangle so that this is true. Okay, so how do we do that? Well, I mean, I don't know the definition of cosecant off the top of my head, but we do know cosecant is 1/sine, right? That's one of our identities. It is 1/sine. So what is this really saying then? What we really have is 1/sine is 9/8. Now, I did show you where to go from here. You know, I think we've done an example like this before. It's really based on cross multiplying, but what you end up getting from here is sine over theta is 8/9. That's what happens. You end up getting sine over theta is 8/9. That's a little bit easier because now we can use SOHCAHTOA. Right? Because sine of theta, as we know from SOHCAHTOA, is opposite over hypotenuse. So remember, this is our triangle. So this is what our triangle will look like. Here I put the angle theta here. Here's our 90-degree angle. Hypotenuse is always opposite the 90-degree angle. Okay? That's always true. The side next to theta, the other side that is, that's the adjacent side. And the opposite side is the side opposite theta. So this side here, this side here, this is good, you know, again, the length is OPP. This is going to be 8 because sine of theta is 8/9 and sine of theta is opposite over hypotenuse. And hypotenuse, then we can make that be 9. In other words, we have this, and this is equal to opposite over hypotenuse. So we can let 8 be the opposite and 9 be the hypotenuse, and we get this right triangle. But what about this side? Well, the adjacent side we don't know, but we can get it though. What can we do? Well, let's label it as x, and we have 2 known sides of a right triangle. To get the remaining side, we can use Pythagorean's theorem. That's what we can do. Pythagorean's theorem. So let's do that. So we have 8 squared plus x squared equal to 9 squared. If you wrote it as x squared plus 8 squared equals 9 squared, that's fine also. They're both the same, so, you know, it's okay. Now, we want to figure out what x is, right? Well, 8 squared is 64. 9 squared is 81, right? So let's subtract 64 from both sides, right? We want to get x. So let's get x squared all alone. So 64 we subtract from both sides. We get x squared equals 17. Well, x then has to be the square root of 17. So that's what this side is. So the adjacent side has length square root of 17. And then the rest is actually easy. You just use SOHCAHTOA and the reciprocal identities. We know sine is 8 over 9. Cosecant's 9 over 8. Okay? Well, cosine of theta we know is adjacent divided by hypotenuse, right? So that's going to be radical 17, okay, over 9, adjacent over hypotenuse. Secant of theta, right? That's 1 over cosine of theta. Well, if this is what cosine is, 1 over cosine, you flip it, and you get 9 over radical 17. Okay, that's good. Now for tangent, that's opposite over adjacent. Opposite over adjacent. So tangent of theta is 8 over radical 17. And then cotangent is, again, 1 over tangent, which means you flip whatever tangent is. You know, you take its, what do you call it, reciprocal. So you get radical 17 over 8. Okay. Are there any questions on this? Any questions at all? All right. I think I'll have to stop here because, I mean, I did have more trig examples, but we have less than 30 seconds. I think we have like 10 seconds left. So we'll stop here. So, okay. So again, if I'll see you, so have a wonderful day, everyone.